Hi everybody, Mr. Clark's here. So I've decided to start making some videos to help you out learning some of this stuff so you can learn exactly what I think you need to know for Algebra 2. Certainly we'll be reading the book and doing some problems out of there as well. But it can get difficult reading and learning from sample problems, so I'm going to try to give you some explanations. So we're going to start with polynomials. That's my unit from here to the end of the year. Polynomials are very, very important in Algebra 2, so you need to learn everything you can about them. So I'll start from square one and go all the way back to the beginning here. So let's start off. Polynomials are made up of terms. Terms are products of numbers and variables. So, of course, variables are the x, y, z that we normally see. So some examples of terms. Well, here I made some up here. Here's a term for you. So it's negative 5x to the fifth. Very importantly, the negative is in part of the term. A times c times b cubed. X just by itself. It's just a term. Surprisingly enough, just a number by itself could be considered to be a term in a polynomial. We have lots of variables in there like we have over here. And there's just another negative number. Negative 6 could be considered a term in a polynomial. Well, what do? Well, we add them all together and like Lego blocks, and we make a very long polynomial. Okay? So I'll give you an example here. This is much more complicated than anything we would probably use. But this gives you the idea of something of how we could just connect these together and make anything we want. So you can see here we got multiple variables here. All right, so we learned a little bit. We're going to start studying polynomials. As far as I can, they're important in Algebra 2. So what are the building pieces of the building blocks of polynomials? Well, these things called terms. They're products of numbers and variables. I'll give you some examples here. And then I connected them all together and made this horrible polynomial here. Let's go on to the next one. So we have some common polynomial names. So for simple things, we can name them. So for the first thing, we have a monomial. Monomial, they have one term. So mono means one. That's a prefix. Here's some examples. 5x, that's a monomial. X cubed is a monomial. And, well, our number, if we start thinking of it as a polynomial, is a monomial. Binomials have two terms because bi means two. So I give you some examples here. 5x plus 2, x minus 3, x squared plus y squared. So we can have multiple variables in here. So binomials have two terms. Here's some examples of what that might be. Well, we can keep going up. Trinomials have three terms because tri means what? 3. Oops. And so we have what? X squared plus 5x. X squared minus 5x plus 2, y minus x plus 3, and x squared plus y squared plus c squared. Of course, we go all the way up to polynomials. Poly means many. So as we have many, terms together, and here I made up the ultimate polynomial. So I threw everything in there. I got fractions, I got decimals. So the main things that we want for the polynomial is we want these powers here to be positive, okay? Integers, okay? Otherwise, you can throw anything in the kitchen sink in there up front as the coefficient. Okay, so we learned some of the common names: monomial, binomial, trinomials, polynomials. 1, 2, 3 terms. But we have a very important property called the degree. So it turns out with all these terms, whoever has the highest power he can and will dominate at some point when graphing it. If x is large enough, he becomes the boss. Okay. But I had over here is the sum of exponents too. So what do you do here? Okay. But he's the highest power. So number 1, the degree is 5. Well, that's pretty easy. You just kind of go down the line here, right? 2, 3, 4, 5. 5's the highest one. Okay, so he's the degree. P2, the degree is equal to 9. So 5 plus 4 is 9. So you might think it's 8, but you've got to add the individual exponents here in the term. So that's a multivariable term. You need to add up all the exponents of each variable to get the degree. So a little tricky here. You might have jumped on the 8, but it's 5 plus 4 is 9. Okay, so the degree is very important. Okay, so it can, that term that has the degree in it, can start to dominate when x is large enough. So that's why it has its own name. It has an important property. We need to know about that. Okay, and you got to watch out for the multivariable terms. You're going to have to do what? You got to sum up the exponents. You're going to get the right answer. All right. Who's next? Well, let's practice finding some degrees. You quickly have a little test here. Not really a test, just practice that. I'll give you some time. And you'll find the degree. So you want to go over the degree. What was the degree? Well, the degree was what? It was the highest power, and if we had multivariables in there, same term, we had to add up all those individual exponents. Well, the first one's easy. This just doesn't have any multivariables, so the degree is just what? Degree is just 3. That's it. Hey, I got 1, 2, 3. That's it. How about this next one? This one's got a multivariable in there. So, what do we do? Well, if we add the 6 and the 3, we're going to get the 9. And so he's bigger than the 5. So the degree is 9. What is this one? What is Mr. Clark doing here? I got 5 different variables in that term. X, Y, Z, W, K. What's the degree of that polynomial? Well, it's 5 because each of these variables has a 1 there. So how do you say 1 plus 2 plus 3 plus 4 plus 5? So that 5 is bigger than the 3 or the 2. I tried to trick you. All right. How about x? What's x? What's the power on x? It's a monomial, right? So its degree is just what? It's not because it's a monomial, but the power here is 1. We're going to write our 1s. So it's got a 1 there. 7. It doesn't even have any x's. How can I find the degree? Well, that's because the degree is what? Degree is 0, because we could write that as 7x to the 0. And anything to the 0 power is 1, and we don't write our 1s. But you can just think of it, there's no, what's the highest power of x? Well, there aren't any x's, so it's 0. And the last one, just 11, 5 plus 6. It's bigger than the 2 plus 5, so the degree is 11. I know I'm kind of quick here, but you can always replay it, pause it. Hey, so it's hard speaking slow because I have YouTube videos. There's a certain limit on the time here. So the first one was pretty easy. I just got the highest power, 3. Here I had a multivariable in here. I said 6 plus 3 is 9. Here I tried to trick you. I had 5 guys here, but each one has a power of 1 that's not written. So add them up for 5. Here's a 1 that's not written. 7, there aren't any variables, but I can write that as x to the 0. Anything to 0 power is 1. So the highest power is just 0. And then finally the last one, 5 plus 6 is 11. What's next? Well, we have some other interesting properties or parts that we've been named, and so we have the leading coefficient. So once we find out that this 5 was the highest power, then we're going to name that -2. So that -2, which is right next to the highest power, he's called the leading coefficient. Notice I included the negative sign with it. So don't make a mistake there and not put that in there. So he's a leading coefficient. As you can see, if it's a single variable and they're all written high to low, he leads it. Okay? He's out front. Okay. The next one, well, this gave me the 5 plus 4 was the 9. That was my degree. So the leading coefficient here is 8. He's next to the guy that gave me the, in the term that gave me the degree. A couple notes here, so make sure you include the plus or minus sign along with the number. See, I put the -2 over there. Don't forget about that minus. And this is interesting. The term that has the largest degree is sometimes called the leading term. Hey, that makes sense now. The leading term has the leading coefficient. Okay? So these all come from when we just had simple polynomials like this, not stuff messed up like this one. And we could order them, decreasing left to right. Everybody lines up really nice. All right. The constant term, that looks confusing. No, that's the easiest thing. Constant term of polynomial is just a term that is only a number and has no variables in it. Well, which one up here is just a number? Let me see. Well, 13 is a number. There's no variables with that one. And 7, that's just a number. But that's pretty easy. So the constant term of P1 is 13, and the constant term of P2 is 7. Nothing tricky about that one. I think you can memorize that one pretty good. Well, let's have a little practice here. See if you can find it. So typically when you have a quiz, you want to find all 3 of these things, the degree, the leading coefficient, and the constant term. So why don't you try that? I'll give you a few seconds here. All right, number 1. Look at number 1. Let's see. What with the degree? You got to go over the definition in your high. Let's see. The degree is highest power. Looks to me like that's going to be what? 7? No, it's that 4 plus 4, right? The leading coefficient is tricky. Now, what number's right next to that? Y to the 4th, x to the 4th. What's the constant term? Wow, this one's all tricky already. Well, you probably knew the degree was 8. 4 plus 4 is 8. It's bigger than the 7. The leading coefficient, what number is right squeezed in here? There is a number there. It's -1. And a constant term, well, there isn't nothing hanging out there. I don't have anything. So I could write +0. Who's going to do that? Constant term is 0. So these are got all the little special cases and tricks sort of in these little practices. All right, I'm going to try number 2. Well, it's an easy one. The highest power is 2. Little tricky, the leading coefficient, I didn't order them decreasing. You might want to throw that one in there because he was on the left, but it's the guy that's right next to the highest power. And of course, the constant term is just that -5. 13x. Well, what would that be? Well, the degree is 1. There's a 1 here, and the leading coefficient is 13. And the constant term is not 13. It's supposed to be 0. So we're going to cross that off and make that a 0. So I made a mistake here, but I want to redo the video, so we're going to put 0 there. All right? Let's do the next one. Well, there's a 1 here. That's the power. 1 out front. And there's a 0 over here on this one. And finally, on the last one, the degree is 6. Why is it 6? Well, you got 6 variables. 1, 2, 3, 4, 5, 6. Add up those ones, we get 6. The leading coefficient is 1. Because there's a 1 hanging out here, and the constant term is 1/2. So make sure I made a mistake here. I said the constant term was 13, but there is no constant term here. All right? All right. Here's your homework. So try these, do the best you can. And, you have to learn this stuff. And so we'll probably submit these on our Google Classroom. Compare answers. And then you guys can tell me if you like the video, what I should do different. And, of course, I shouldn't make any mistakes. But, so many numbers here. Luckily, I caught my mistake on that one. So anyway, hopefully you enjoyed this video. We'll continue next time. See you then.